Let's talk about derivatives of inverse functions, inverse trig functions primarily. It's not to say we can't do some other ones too. Let's just stick with the trig functions today. Okay. So, what if we had this? You have the derivative of the arc sine of x. Yes? Now, first thing, Lil, is I'm going to write that as y equals arc sine of x. You with me on this, kid? This is the trick. I'm letting you in on the secret handshakes to the math club. Okay? We're not excluding you. We're not mocking you because you don't know them. We're telling you what they are so that you can play along too and be a big kid. Okay? Now, here's the trick. We're going to take the sine of y, which is the sine of both sides, what we're doing here, is equal to x, yes? That's literally all we're doing. So listen, when I hear the sine of an angle, I think right triangle. And I'm not wrong. The sine is the opposite over the hippopotamus, yes? Meaning this bottom side is 1 minus x squared square root-icated, yes? Am I right? I feel like I am. Let's take the derivative, shall we, Connor? What's the derivative of sine? Cosine of y. Oh wait, but it's y, so I better have a dy dx. And what's the derivative of x? It's 1. And the whole game is to solve for dy dx. So dy dx is 1 over the cosine. And of course, if you understand that that's just Cho-Shikao, that is secant, yes? Right? It's the secant of y is what we're saying. Wait a minute, well, y is right here. What is the secant of y in this triangle? Look at it. Secant is 1 over cosine or hypotenuse over adjacent. This is the derivative of arc sine. Now, look at that problem, Hannah-Morse. That 1 over the square root of 1 minus x squared. Is there any values of x that would be a problem here, dear? 1 and negative 1 would have a problem, huh? But that's okay, because friends, you may recall, what is the domain of this function? The domain of this function is, if you have a sine ratio, you're guaranteed to be between negative 1 and positive 1, yes? Right? What are you doing to her? You stop it right now. So, we know this is the domain of that function, yes? Right? What does arc sine look like? Perhaps it's been a while. Perhaps we need to look at it again. Perhaps we've forgotten. Perhaps we should graph it. Arc sine x. Oh, there it is. But listen carefully. What is the slope right here at 1? I feel like it's vertical line right there. And why is that? Well, look at the graph. We'll tell you, right? Look at it. What if x was equal to 1? You'd have 1 over infinity, which would be, a vertical line, right? Because it would have infinite slope. Same thing at negative 1, right? Yes? Look at that thing. 1 over the square root. Is it ever going to be negative slopes? Never. Geez, I wonder what the graph looks like. Geez, it's always going uphill. Who saw that coming? Never. Now, interestingly enough, Angel says, what if I want to talk about arc cosine? Totally digging that, by the way. Nice job. Notice it also is defined between negative 1 and 1, right? Because you can only have cosines that go between negative 1 and positive 1, yes? It also is going to have a problem at plus and minus 1, true? But the slopes on this guy, what? They're always negative. But don't they look like they're always the opposite of what the other one was? They're like completely opposite, but they're the same values, right? So wherever the other one was positive 1, this is going to be negative 1 and so forth, yes? Interestingly enough, that's a fact. If you do this, you have the derivative of arc cosine. Of course, that's y equals arc cosine. So cosine of y is equal to x. What's the derivative of cosine? There's your negative right there. So dy dx, negative 1 over sine of y. What do you mean sine of y, Mr. Groom? I don't know. It says that the cosine of y is x over 1. That's what it said. That means this side over here is 1 minus x squared, correct? Pythagorean's theorem and all. Oh, by the way, oh, shoot. I wish I could pronounce Pythagoras like that guy yesterday, huh? Alright. You should watch the video, Haynes, from yesterday. You might enjoy it. So it's negative 1 over, and then listen, if you look at it right here, check it out. This guy right here, 1 over the sine is a hypotenuse over that fella, so it's 1 over this guy. Notice how it's exactly the same as for the arc cosine, except for that pesky little negative sign, yes? They are the same. Now, I'm not going to bore you with the details, Hannah. I'll leave secant and cosecant and cotangent for you to do, but suffice it to say they're exactly the same tricks. Okay? But what would happen if we wanted to take the derivative of, I don't know, what's the derivative of the arctangent of 3x? Well, first of all, your first thought might be, isn't this just chain rule, Mr. Groom? And now that I know what arctangent is, couldn't I just plug in? Probably. But let's do it the hard way the first time, okay? So, remember it's y equals arctan of 3x. That's not wrong. So then, the tangent of y is 3x. Again, you must draw a triangle. Listen, back in the day, I was kind of a lazy loser kind of a person. And when the teacher told me to do the right-hand rule, I frequently would use my left hand because it was too lazy to put the pencil down and use my right hand. I thought of it more of a suggestion, which of course didn't work very well. I remember this one time I missed every single problem on his physics assignment. He goes, show me what you're doing. So I showed him and he's like, what part of right-hand rule do you not understand? I'm like, well, what difference does it make? He's like, it's only completely ass backwards. And I'm like, oh, I guess you're right. Oh, yeah. But second of all, back in the day when I did these problems, Brooke, I would always not draw the triangle because I thought to myself, why do you need to draw a freaking triangle? Why do I need it? Because without it, we're kind of screwed in a minute, okay? You must draw the triangle. Now it says that the tangent is 3x. That's 3x. It's opposite over adjacent. Yes? That's huge. Now what is the derivative of tangent? Secant squared of y dy dx. And what's the derivative of 3x? 3. That's right. And so dy dx is 3 over secant squared, or if you prefer, which I do, 3 cosine squared of y. Nice. Right? Because 1 over secant is cosine, right? Nice. What is the cosine of y over here? What's the cosine of, look at this thing. What's the cosine of y over here? Well, I don't know. I'd have to find the hypotenuse, wouldn't I? And what would that hypotenuse be? I believe it would be 9x squared plus 1, wouldn't it? Yes? Yes. And so, it would be 3 times, the cosine would be 1 over this fella squared, which would just be 3 over 9x squared plus 1. And that thing right there, Hannah, is the derivative of the arctangent of 3x. How do you like, Mr. Grimm? Isn't there an easier way? Okay, there's a faster way if you don't screw it up? Yes. Do I recommend it for your beginners? Not for a while usually, but here is what would it be. Listen, if you just saw this beast and you said, I'm going to take the derivative of it, and you say, wait, this is just a function in a function, which, by the way, you're not wrong. What's the outer function? Is 3x the outer function, or is arctangent the outer function? Arctangent. And what is the derivative of arctangent? It's 1 over x squared plus 1, yes? That's what it is. So we know that the derivative of arctangent, what are you doing? Is 1 over x squared plus 1, right? So it's going to be 1 over, but what's my x this time? It's not x, it's 3x, squared plus 1. Are you with me in this? It's just like we took the derivative sine of 3x, isn't it? Yes? What's the derivative sine of 3x? It is cosine of 3x, yes? That inside piece stays the same, right? So wherever there was an x, we're going to put our new function into it, yes? Which our function is 3x. So it's 1 over 3x squared plus 1 times the derivative of 3x, which is 3. And look what we get, friends. That's 3 over 9x squared plus 1. And if you do it right, that's a good way to go. But if you suck at that, or you don't pay attention, or whatever, you may not. Results may vary. Results may vary. Again, Mr. Haynes, you've been gone. We've missed you. I have, anyway. I don't think your girlfriend did. She talked a lot of smack about you. Actually, that's not true. She was like a mess. She was disgusting. She called me for a whole 2 hours, Mr. Groom. No, that's not true. Anyways, listen. So listen. This is the outside function, yes? What is the derivative of arc sine? That's 1 over square root of 1 minus x squared, yes? Right? That's what it is. But we don't have x, friends. We have x over 2 squared. True? Times, what's the derivative of x over 2? 1/2, 0.5, whatever makes you happy. Sure. So technically speaking, this is correct. That's not wrong. Some people might try to clean that up a little bit. You don't have to. I'm just saying this is true. Look, I got a common denominator. How exciting for me. Yay. Right? And then I'm like, wait, that's a 2 right down here, yes? So I could pull it out. That's a 4, I mean, down here. I could pull it out. It would become 2 over 2. That's this 2 here would come outside. Right? So that is just this guy right here. These two should be the same. Okay. But listen, technically speaking, that's not wrong. Okay. It's just the book might take it a step or 3 farther. That's all. Yes? Why? What's the matter? Look, I got a common denominator, 4 over 4, right? Right? Yes? So that's 4 minus x squared over 4, right? But that 4 is a perfect square root, yes? So if I square root it, it's a 2 out front, right? So it becomes 2 over 2 out here, right? 2 over 2 is just uno. Sí. Muy bueno. Yeah. All right. That is, listen, that is, in essence, what you're doing in that section. There is a couple other ones that I want to look at next week. I'm going to save them for a video, I think, on Monday. A couple of them. So you have to go on Shroom. There's a couple on there that weren't trig functions. They were like inverse functions, but you didn't really talk about them that much. We're going to talk about them a little bit more. So I covered the inverse trig ones. I personally think they're the trickiest of the bunch myself. I think they're just a little... They're not hard once you see them. You can't forget it once you've seen them a few times. But the first time you see them, it's kind of like, that's weird. You wrote it like that? Yeah. So I can use implicit differentiation on it. Okay? Now, there's some of us who I really like this chain rule bit. Good for you. The rest of us are going to do it the hard way. Like on this one here, Mr. Groom might have written this as the sine of y is equal to x over 2, yes? So in this situation, there's y, here's x, here's 2. You with me in this? So this bottom side is, check it, 4 minus x squared. Huh? Huh? And so when you put it together, right? When you put these pieces back together and take the derivative of it, you will find that it's, what is it? Well, it's this sine, cosine, secant. It's 1 over secant. Yeah, so it's, well, somewhere I dropped something somewhere. Maybe there should be a 2 floating around. Well, whatever the deal is, you'd get it the same way both ways. It would work out and be great. But anyway, that's the idea. So Monday, the quiz will cover